In decision making, we saw if. We did not see a switch case. So let's first add a class, new class, and see, when we create a class, we can name the class as test switch anything, and if you want to have a main method in that, we can click on this. Not necessarily we'll have main methods, right? If we already have one main method, we'll not create another main method. So this is a new class, so we'll create a new main method here. So I'll say finish. So I'll create test this thing. Okay, so what I want to do is I want to have multiple conditions set here so that I'm able to switch between them and do something when something happens and something else when something else happens. Okay, so I'll say there's an integer called number, and this value is 10, and then I'll say switch for number. So what I'm doing is I'm going to use the variable that I want to check the condition for. This is equal to, this is as good as saying if the number is equal to something. Now this is just the if part. We don't say the equal to part in switch. We say that in a case statement. So we'll say case 10. So that will be the number equal to 10. If it is 10, then we'll say system dot out dot print ln something, and then I'll put a break statement here. I'll tell you just in a minute what break does. Copy that. Okay, I'll say there are 3 possible outcomes. Okay, so the number, if the number is 10, then I say this. I'll say the number is whatever the number is. You understand? So I'll say the number is whatever the number is. So plus number. And same goes for all the others also. Right. What is this case? Case means for any available value of that switch that we are doing, if it is any of these values. So in my case it will run the first one, case 10, right? If I would have said number is equal to 12, then unlike if, it will not go through other 2 cases, it will only go through that case where it finds the value. If I say number is 12, right? So it won't go to 10, won't go to 11, directly will jump to 12, and after it jumps to 12, this is what it will execute. Once it executes that, this break statements, all these break statements, they stop the execution of the code and directly jump to the end brace of this code. They directly jump to the end brace. What if I don't write break? Not writing break means that even if the condition is satisfied, you'll go on running the next condition. This is allowed in Java. In C#, which is a .NET based language, it's not even allowed. You can't just not write break. So if I just remove break, it'll still be okay. It will not give me a compilation error. What it will do is, it will run this. If the condition is 11, it will run this, and then it will also run this. So I don't want that to happen. Break is a statement which is also known as jump statement. It's called a jump statement. It allows you to jump from one line of execution to another line of execution, right? In our case, break stops the execution, right? There's another one called continue. We'll probably see that later. There's continue, there's break, there's go to, there's return. These are all jump statements. So the last part in this is known as default. If none of the values match, then this is what I say. The number is not found. Makes sense, right? And again a break. Should not break out. should have a break. Well, here I can use this go to statement for you. Here go to won't work, so I'll probably tell that to you. I'll just put a break here and just keep it like that, and let's say we run it. So the value is indeed 10, so it says the number is 10. Okay, now again in Java 6 we can't compare strings for a switch. For example, if I want to just choose a string, I'll say string number equals to 10. I couldn't do it like this. This could be a problem, right? Because Java 7 and 7 onwards is capable of doing this, not the older versions. So you can compare strings also, but not in older versions. In the new version you can. So that is about a switch case statement. The difference between a switch and an if is that if goes through each and every line of code and then executes what actually matches the condition. This on the other hand jumps directly to the case because it actually knows the physical availability of that number. So it jumps that directly here. It knows that case 10 is here, it executes this. If it is 11, it doesn't go here, simply goes here directly and executes. Fine. So that's about this. There's another one known as a ternary operator to make decisions in your code. Let me just remove that. Okay. Now, what I'm doing is I'm saying that if I have a single condition, I don't want to write if else, I don't want to write switch, just one condition. What I can do is I can write a ternary operator. Ternary operator basically uses two operators like this, question mark and this. These two operators will allow me to write a decision making code in one line. For example, if I have something like this, int I equals to 10. Fine. If I want to check if I is 10 using a ternary operator, there are three things that you need to do. First is write the condition, right? Then put a question mark. After the question mark, write the thing which will happen when it is true, and then this when it is false. So this condition if true, this part will work. If false, then this part will work. So let's see. I'll say string result so the result of I being equal to 10 or not being equal to 10 will be stored in this. So I'll say I, that's my condition, right? I'll say question mark, do this when it is true, so it is 10, or maybe I'll say I is 10. This will happen when I is not 10. I'll again explain. This is a ternary operator because it uses three operands and two operators. Three operands are these. Generally an equation will have two operands and one operator. Ternary operator has three operands. Operands are the components that act upon those operators. What operators do we have? Question mark and colon. So these three operators, condition, what happens when it's true, what happens when it's false, these three, they act upon this question mark and this. That's called a ternary operator. It's very easy, very simple to use. Okay, now one thing that you must remember is that ternary operator returns what you are writing here. So here I am writing a string, so I must store that within a string. Right? You understand? After the question mark I am putting a string. If I put an integer, then this should be an integer because I'm storing that here, right? So it is throwing this back into this, throwing this back into this. If I is 10, then it will throw this into this result variable. If not, then it will throw this into the result variable. Okay, let's print this out. Okay, so I'm printing out result. Let's run that. I is 10. So without having to write that if and switch, if I have just one condition, it makes it very easy for me. That's what it's supposed to do. That is exactly what it does, but only and only a single condition can be used here, right? We have not worked with strings till now, right? We have just worked with numbers. What if I'm comparing two strings? Can it be compared? Well, absolutely it can, but the thing is we have not seen how to compare strings. Well, see, I'll give you one tip which will work forever. If I'm comparing two strings, the problem with comparing the strings is this. I'll say, string s equals to, let's say, hooray, and then I'll say string s1 equals to hip hip. Alright, now these two strings s1 and s, to check whether they are equal, if I just put them like this, see what happens. I'll say just check whether s is equal to s1. That's fine, right? It says okay, that's okay. But what is it doing basically? String s is basically a collection of characters. It doesn't have the value hooray in it, no. It has the collection of each character HURRAY together, which it is referencing. It's not a direct value that is stored. It's the reference of these values HURRAY stored inside a string array, character array, sorry. So if I do something like this, let's see what I get. So it should say they are equal and they are not equal.
Is it case sensitive?
Yes it is. Yes it is. Case sensitive. Java is a case sensitive language. It works with variables and the value of variables. Case sensitive. They are case sensitive. In certain cases, I'll tell you where it is not case sensitive. That I'll tell you. Sometimes what we do is, let's say the string value is true, TRUE, and boolean takes a value true. But string true and boolean true are not the same, right? Boolean true means yes, and string true is any other string. But if, let's say I want to convert that string true to boolean true, so even if that string true is capital TRU or small TRUE, it will convert to boolean true, because boolean true is small TRUE. So even if that's capital, it will convert. So that is fine, but here it won't be fine. So case sensitivity is an issue. Okay, so I'll say they are equal and they aren't equal. They aren't equal. Okay, so result will be stored in that. So I'll say run. Okay, it says they aren't equal. Well, let me just put it like that. So it says they are equal. What is it doing basically? Is it comparing the string or is it comparing each of the values inside a string? Well, what it actually does is it compares each of the values one by one in the string and not the string directly. Not the string directly. So if I do something like this, so there's a blank character. Ideally, different languages work differently for this kind of scenario. So this being also a part of a string, it's a blank character. What it does is that in the string, H is at 0, U is at 1, R is at 2, R is at 3, A is at 4 and Y is at 5. It just compares Is this 0 h? No, it is not. Is this just one is enough? Just one. It doesn't go ahead and compare the remaining character list. No, it doesn't do that. A more efficient and more correct way of comparing strings is by using a method inside a string class itself called equals to. String has a method like that. So if I say s1, sorry, s dot equals, so I just want to compare it. So s dot equals, so what does equals do? I'm not sure. I'll say okay, let's try. Does it mean that, okay, if I take, it says, just one second. You've got length, you've got equals, ignore, that's fine. Let it be, come down. This equals returns a boolean, see? It says I've passed a string and it has been used already. And it returns a boolean, so it gives me true or false. If it is equals, it says yes. If it is not, it says no. So that's a better way to use it. When we reach complex objects, the first thing that we do is understand string manipulation, how to manipulate strings. That we'll do tomorrow with a lot of things about strings. Strings are quite complex, so probably a whole class session will be enough for that. Let's jump to loops. We've got 4 types of loops, right? We've got a for loop, we've got a for each loop, we've got a do while loop, and we've got a while loop. A piece of code executed time and again till the time a condition is false. So unless the condition is false, it's going to run that piece of code till the time you ask it to. So let's start with the for loop. We may not go through for each loop right now. For each loop, I'll just tell you what that is, but we'll not write it. We'll start with the for loop. I'll put the word for and say it's got the code in it. See, it says for, do you want the for that iterate over an array? So array is basically a data structure containing certain values. So I can do something like this. I can create an array I and pass certain values to that I here. Right. So it's an array that holds these many elements. If I create an array of character types, and each of these must be characters, it's wrong right now, then this becomes a string. 1, 2, 3, 4, 5 together becomes a string. That's an array of characters and the name of the array is I. So similarly, what I'm doing is I'm creating an integer array and storing these values. A lot of people actually make a mistake when they try to understand loops. Loops not necessarily work with arrays. Not necessary. It says for, do you want to use, what is it asking? Is Eclipse is saying, do you want to use for to iterate over an array? So let's say you have an array that has 5 values. What could you possibly do? I want to say loop through this array till the time you find values less than 3. The moment you find a value more than 3, stop. That's what I can do. But is it all that I will do? No. A lot of other things can be done. It says iterate over array with temporary variable. Iterate over a collection. That's again like an array, but a little different than that. Iterate over an array or iteratable. We'll use the first one. This one. If I say enter, it will have everything for me. It says for in j equals to 0, j is less than what? The length of this array. I dot length basically gives the number of elements that are there inside an array. That's 1, 2, 3, 4, 5. If you want to print out the length to see whether that is the length, you can say system.out dot print ln, and what do I want? I dot length. This is what I want to print. Maybe I don't want to run this now. If you want to comment it just like that, press control / it will comment everything out. You can press it again to uncomment it. So I'm just printing out the length of this array. Let's go and click on run. See guys, I'm not teaching you an array today. I'm just showing an example what this could be used for. Maybe I don't want to use this at all. Okay, let's use a more simpler example of a loop. I'll say int I is 100 or maybe 1000, and then I'll say for each time. Now for basically takes three things. The first is the initialization of the variable to be compared to. By default they call it I could call it j, so I'll say int j equals to 0. That's the initialization. I could declare j outside and use it inside. Could be okay. I could have said int j outside, int j colon, semicolon, sorry, and inside I would have said j equal to 0. That's the same thing. But in that case, j is available to everyone, not just for loop. Here j is only available to for loop. I can't use it outside for loop. Right? Okay. That's the first thing. Second is the condition. For j starting at 0, till the time j is less than I. Now before going to the third part, I'll just say that do something. What I want to do is print out j. So I'm basically printing out j starting at 0, j less than I. The third thing is the increment, right? I must say by what measures is j increasing or decreasing. I could say j minus minus also, but if I say j minus minus, it's at 0 right now, it wants to reach 1000, it'll go further negative and it'll be a problem, right? I could say j minus equals to 5 also, or sorry, plus equals to 5. So j is going to increase by 5, and each time I'm printing this. See what happens. I'll run it, and depending on my processor's speed, it runs pretty fast. Starts at 0, adds 5 each time, goes to that point, comes here, value is 0, goes back. Is 0 less than 1000? Yes it is. Add 5, come back. Is 5 less than 1000? So till the time it doesn't reach 1000, it's going to run this and it's going to do it, right? Now why does it make so sense using this with an array? What we do is we say loop across the array how many times, for the number of times there are elements in that, and the number of elements is retrieved by that length property of the array. Every array has that length property. Every collection also has that length property. We'll probably see that later. Okay, second is also a for loop, but it is called a for each loop. The syntax is exactly the same for a for each loop. Now I'll not tell you what a for each loop does in code right now. When we reach collections, then it will make more sense. For each loop basically does not take this initialization condition, no, only the condition, right? For example, I'll say that this is my collection. This is a collection of sheets, right? If there is a way to understand that there are 5 different colored sheets in this, and using a for each loop, I'll say for each colored sheet that you have in this file, if that colored sheet is black, return it. So iteration, so it goes through the whole file tries to find the sheet that is black amongst other sheets that are colored. So it knows how to find it. But here it does not take any increment, it just returns elements. It does not take any increment. It takes condition, does not take any increment, no initialization required. So this will make sense when we do a practical example of a for each loop. Let's jump to a while loop. Yeah.
For the loops, in
Hmm.
case if we give something which is irrational, we give it a calculation which is irrational. So for how long does it go on? Because they never stop. Something like pi, if we can give it a calculation.
Correct. So if we have a value of pi, it won't stop. There should be a way to get out of the loop then.
Then is still
If you have a recurring number like 22 by 7, right, you'll not be able to fully divide it, right? So in that case, there is that will be an exception. You see, I'll do something like this. I can hold a value of 2 billion. Let me use a long here, and I'll say long L is equal to, it can hold a very long value. I'll start with I think it can even go more than that. Okay, and then I'll say long J, and I'll say okay L. Okay, now see, this is going to start at, sorry, this is going to start at 0 and then it's going to add 1 to reach here, right? That's a very big number. Now I'll tell you what will happen when I run this. See, depending on my processor speed, it's going to do what's going to do, right? Now what we need to understand here is, I'll just stop it for a second. When it starts here, the value is 0, it jumps here, prints 0 as 0, j as 0, goes back, comes with 1, and then goes on and on and on and on and on. Okay? Now the thing is, at some point, it will run out of memory. The value of j basically, from point 1 to the last point, is storing that value. It's not a new variable that is getting created. It's the same j that is holding that value 0 and 1 less than this 555, whatever this long string is. The system runs out of memory sometimes when you are storing, when system cannot manage memory in terms of assigning the value of the variable, assigning the value of that whatever is to a variable of a certain kind. Now in case of an irrational number, let's say we keep on dividing numbers that are not fully divisible, right? What happens in that case is each time we get a new number, it's stored in that variable and it goes on and on and on, right? Now when we open Eclipse, there is some amount of memory dedicated to Eclipse by my JRE. Runtime environment assigns that memory to it. The moment I run a program that never ends, it doesn't come out of that, it's an infinite loop, it basically gives me an exception. It stops the execution in between, saying out of memory exception. In that case, to overcome that, we have to use exception handling. That is one of the topics that we are going to discuss. What if someone divides something by 0? What will you do? You don't have an option there, right? You won't know what to do. So divide by 0 is one of the exceptions that we have to catch. So that's basically exception handling. All the mathematical things which may cause memory overflow, binding. Sometimes what we do is we try to bind one data type with another data type. Now I'll give you one example which is probably important in terms of, let's say I'll use short s is equal to 30, and I want to print this out. Okay, I'll print this out like this. So I'll print the value of s, but not like that. I'll say the value of s is, and then plus s. This is going to run just fine, because see what will happen. This plus operator decides what is going to happen, whether it's going to add or whether it's going to concatenate. On the left side of the plus is a string, so it doesn't matter what is on the right side, it will add that to the string and make the whole thing as one string. But what happens if I put this here? Now on the left side of the plus operator there's a number, there's an integer. Short is an integer basically. It's an integer of 16 bits. So what will it do? It will work. In some languages it doesn't work. In some languages it gives you an error. Why? Because it thinks the one on the right side should be an integer if the one on the left side is an integer. But in Java, plus operator, the existence of string on either side of plus makes the whole thing a string. Right? That is one. Second is concatenating a number like this. So there's a certain way in Java where you can, let's say this was a boolean. Sorry. It's a boolean b. Its value is true. Okay. I'll try to concatenate this. If I concatenate this with string, then it's easy. It's very easy. But if I try to concatenate with an integer, I'll say int I equals to 10, and then I'll say I'm saying b plus I. You understand what I'm doing? Take my mouse there. It says is undefined for the argument types boolean and integer. It says there's no operator that is defined to add. It's not saying it's an error. It says there is no plus operator which can add a number with a boolean. In some cases, like here, it gives me a compilation error. In some cases, it will give me a runtime exception. It will not check that here. In that case, what will we do? Handle the exception. So exception handling is one of the major things, most important things that we do on a day-to-day basis, because the user input could be anything. We'll say enter two numbers to operate. Let's say the user enters a number that will give me infinity. So how will I handle that? I have to handle that. That's an error handling. Exception handling. Error is something that happens with your knowledge at the compile time itself. Exception is something that without your knowledge it happens at the runtime. It's a not foreseen. You don't foresee that error, and it only happens at the runtime. Okay, let's do while and while quickly. While checks the condition and execute once, and I'll say while the value of I is equal to 10, print the value of I. You see, the thing is, the value of I is 10. it will always be 10. So this will be printed out till the time the value of I is either less or something else than 10, but not 10, because I'm saying the actual value of I is 10, and then I'm saying while the value of I remains 10, print this, but I is not changing, right? I is 10. So this will be an infinite loop. I will always be 10, right? That's what an infinite loop is. So these kinds of loops must have a way to come out of it. So I'll say I plus plus. So at what point are we starting? We have to start at some variable. So we give it a variable name. So I'll say int j equals to 0, and I'll say while j is equal to I, do this. We're printing this first. One second. In some cases, do while is more natural than using while, even though the condition setting to false, we will use it because it runs at least once. It runs the code block, whereas while does not run till the time the condition is not set to true, right? Okay. So these are loops. I've put new exercise files here so you can. I've deleted the old one. Someone has probably deleted the bin file, so I'll just put these things back again. Methods and methods overloading we saw, right? Using one method to using a same name method to do things differently by using different signatures that we have seen, and go through this simple calculator application, and then tomorrow we'll jump to complex objects. This is where we start with strings, string builders, dates, debugging, correction, custom classes. There's a lot to be covered, so we'll probably cover it by next week. So tomorrow we'll cover this complex objects. I'll just give you a little insight of this before we leave. The idea of complex objects is that they are not values. They're not values. They store a reference to a value. Now what does that mean? In Java programming, there are two types of values. One is the value itself, like this int I is equal to 10, or maybe something like this, char c equals to a single Unicode character. That's a character, sorry. It's a single Unicode character, right? I can put something like this also. But when this, what happens is that character gets a memory location. Right now it has got a memory location for a variable c who has a specific memory as a, right? If I do something like this, I'll say char c1 equals to c. So even c, if I print c1, it will be a, right? So what it does is it simply copies the value directly. It's a primitive data type. Whereas if it's a string, string basically refers to each of the characters inside a string, like this. So I'll say string does not hold the value itself. It holds the reference to each of these characters inside an array. So it does not copy by value. It copies the reference of the value. So if I do something like this, So here I say s1 equals to s, so s1 also becomes hello world. But if I change the value of s, even s1 changes. In this case, if I change the value of c here to b, c1 still remains a, because c1 is a character variable which has its own memory location, whereas string is holding a reference to this. So if the reference changes, the value changes. Now this is what a complex object is. Like, string is a class. We write this like this, and these classes basically are stored in packages. If I want to know where is string stored, so I'll say control space, so it will tell me string is this java.lang, and then I've got this date. So date is in this Java utility. Date d equals to new date. That's how you create. Yesterday we saw that, right? To create a new class. Now this is a class that I have not created. This is a class created by .NET, created by Java class library. So I said d dot get time. What time? Current time. Get date. So I'll get the date, and then let's say I want to print out okay, this is deprecated, so let's use some other version of that. Get month is deprecated, get time is there. Okay, so if I just want to print this out, system.out out.print, I can simply return what is being returned by this. It's returning me time. Run. So it's returning me time in some format. So if I want to get time off today, I'll write another method. So basically all these methods are inside this class, which is a package. Actually, I've imported a package. We'll talk about packages, classes, and these complex objects in coming days. And we are going to implement everything that we've learned till date, operators and methods and loops, conditional statements in that. Okay. Java starts with complex objects. Everything that we have covered till now is just fundamentals of a generic programming language. Switch, do while, for each, it's there in all the languages. Maybe the code is a little different, but if you just sit one day, you can learn a new language based on your understanding of Java. You can learn C++. It's so easy. But there are certain things, like I said, strings cannot be compared. They can be compared in other languages. So there will be small differences, but yes, once we understand the behavior of all these things, that how does string behave? Can I create my own type of string based on strings that are already defined? So till we do that, we're still not sure what we want to do with core Java, right? We'll do that tomorrow.